you've heard before was the draft from yesterday when I heard that I'm doing the presentation. Right now the main theme actually became automation, but I'm going to touch on the package, custom packages, because that's what we do to some extent, and basically why do we do automation and what do we do about it. Hope it will be useful in some ways. So why do we do automation? Basically, maybe I'll start with asking, is anyone actually deploying OpenStack here in an automated way? Doing it by hand? Okay. So by automation, basically, I mean getting it up there in some repeatable way. So basically we can say that this is the release we're doing, and that's what you're gonna get, whether it's some custom development server or testing environment or production. It's basically that deployment, you're gonna get it because it's repeatable, it's always gonna be the same. It's partial verification also to some extent, because we know that if we run some tool that just converges the system to some known state, it's either gonna converge or not, or it's gonna fail. So it's half verification. We can enforce lots of things like versions, so basically that's useful because, well, we're doing an upgrade or release or something like that, and we want to enforce that all of the servers run exactly the same config, run the same version, run the same environment. And, well, basically, it provides with many projects that are going on. So we've got Nova, we've got Swift, we've got Glance, we've got Keystone, and on and on. Now we've got even more projects with Auomatd and things like that. They'll just, there needs to be some interface between them to basically say, hey, I run that service on this place, and I run some other service in this place. Keystone does that with endpoint to some extent, but you still need to somehow manage to say, hey, where do I look for Keystone? What are my credentials? How do I get there? So that's what we pretty much mean by automation. And there's loads of choices of how to do that really. So there are main themes, so there are pull automation. So basically you've got some agents running on each server and asking, hey, what do I do now? What do I do now? What do I do now? There's push automation like Salt or Juju, for example, does. Oh, Juju is mostly orchestration. Well, orchestration and automation, automated deployment tool. It does the same job. It basically says, hey, those servers do something. And on the other hand, on the other side of the spectrum, we've got also network-based and image-based putting, where it basically prepares some image that needs to be run on the servers. And, well, that can be extreme, as in every time you update something, reboot the server so it gets the new image, or you just have half-half situation where you deploy from some image that's already there, but then do the updates via some other tool. And there's lots of helper projects which actually supplement all of the other methods, like in Collective Fabric, where basically all the management jobs that you normally run, you can implement them. And, this is one of action that I could implement as a automated thing. They could be running all the time, but this is just what I want to do now. There's something like, I've got kernel upgrade, now I need to reboot those servers, and I don't want to reboot them one by one, which doesn't really fit well into all the other areas. So they can be mixed and matched. They do pretty good stuff. I guess it doesn't matter what you use, but I would say deploying something like OpenStack without any automation in place is slightly insane, because all of those small differences, small issues between different deployments, they just accumulate over time, and either you're gonna force it into one state, or it's gonna diverge pretty quickly.
Do you recommend any?
We're using Chef and Fabric for one-offs. Like I said, I'm not really a fan of the pool ones, but Chef is the least bad of them. there's lots of projects that implement that. There are chef cookbooks, there are puppet manifests, and there are so many editions of them. And I think half a year ago there was a big topic on the main English to unify the chef cookbooks, for example. But I'm not sure whether it's actually worth it. That's completely my position here, where I think that once you start going to a larger system than your small test deployment, you're basically going to accumulate site dependencies. Like, now I need to install some very specific version of libvirt, but this cookbook only depends on libvirt implicitly. But I already need it for reason X, and now I need to actually restart some other service before I need to restart libvirt when it updates. So it's just going to diverge at some point. So I think they're a very good start if you just grab one of the cookbooks available, but probably not going to last long. It didn't for us, at least. So there's loads of other examples, backups, monitoring, how do you provision credentials and things like that. They're just going to be different from each environment, and that's a normal thing, I guess. It's just whenever you leave the small environment, it's going to happen. But I mentioned packages because I guess that's an important thing when you deploy, because you've got the different options, whether you deploy from packages, whether you install from just Python itself, whether you do your own PyPy mirror, whether you use your own repository. And yes, there are good and bad sides to both of them. I guess developers would much prefer if you did everything from setup.py. On the other hand, it's easier to operate the system when everything's in the same box. So basically, once you package everything, all the dependencies are explicit. You don't have the situation where you've got one system to manage one thing, another system to manage another thing, and hey, soon you'll have something that actually runs on Ruby, so you'll have gems, and you've got one packet that is in Perl, so etc. etc. So I think there are good reasons to use or not some system, but I would still say packaging everything is nice once you can afford it, because it just keeps things consistent. It keeps things easier to install, and basically once you want to automate something and stand up environment in an automatic way, in a kind of repeatable fashion, it's just easier to say, this is my repository of software, because that's my local repository that, for example, doesn't depend on internet access, doesn't have dependencies that I don't have. Everything's in one place, I install from here. And that's really simplifying the whole design. So even if you modify something, we do. We did modify a lot, at least. We're still going to modify a lot locally. For example, before something gets into the mainstream, we need to into upstream master. We still want our change to be built and deployed right now. We don't want to wait for the review, even if it gets accepted after a couple of days. We want that specific fix now because of reason X. And it's a good way to manage this. Basically, we're building our own custom packages and deploying them as if they were coming from upstream. At some point we'll merge again, and just a nice way to do it. So when you're running automated system in practice, so some of the hard things that would be hard if you did stuff by hand becomes really simple. Like I mentioned, discovering other services. Before Keystone it was much harder. With Keystone it's a little bit better, but there are still things like, where's my database, what is my password, what's my username. I don't know it on this host, but some other host knows, so I better take that information from somewhere. As long as you can enforce some interface between all those services, and say, I'm calling, say, that abstracted function to get my MySQL location or RabbitMQ location and access details, it's pretty cool. this allows also to make config files more static. So I'm saying more static. Of course they're static, but what I mean is you know that the things that you put in the config file are just gonna stay the same. If you've got some crazy setup where things are moving around, you don't need to build up some dependencies on how you connect all the pieces. All of the outside, how does infrastructure come together, comes from the automation software. So for example from Chef, it's got all the information you need. You just put the actual facts in the config files. You don't mess around with generating them some crazy way. And it allows to just eliminate a couple of layers, like I'll resolve all the host names, because the DNS will go down at some point. It just does. So might as well make sure that system continues to run them. The things like list of modules that started in SX and Folsom. Basically, you either need to list something or say, yep, load the standard package of modules. I think for scheduler, for example, for filters, it either has the option of loading everything it finds or specific things. And setting it up front basically prevents errors. There are a couple of things that can happen when installing a package, and you don't want to end up with an inconsistency. If it's gonna fail, let it fail when it's starting, because it cannot find the module that you specified, rather than select all the modules. Oh, but I'm just missing one for some crazy reason. And you can simplify things like password management. Instead of coming up with, yeah, I'm setting a new environment, I need a random password, I need to put it here and here and here. It's like, if there's no password, create a long random one, done. It's taking away lots of work. On the other hand, once you're going into managing a bigger system, some of the things become crazy. Because, okay, if you want to install a package, you do apt-get install some package. What if you want to have some specific version, because you have a couple of repositories with different versions? Okay, up the version. So what if you want to downgrade it? Oh, you have to actually force it. So what if there was some config code that was modified? Another option. What if someone actually stopped the apt-get before and the database is marked as not closed correctly? Oh, you have to actually fix it. So there are things that are just going to accumulate over and over, because you're doing things to the system that people don't normally do in a manual way. So we ran into a similar issue before, actually quite recently with AppArmor, where basically we reload the profiles all the time, because, well, it's sometimes cheaper than just checking if they got updated since the last time. But apparently that's not the common way to do it. So there's a memory leak to get an update from Ubuntu kernel. I guess in the next couple of days, fixing that bug. There are also other things to consider. There are strange oddities like libvirt and evtables. Libvirt checks if evtables exists when it starts up, not when it tries to execute it. So you install libvirt, it starts up, you install evtables, it's there, but libvirt will say, no, I can't do anything, there's no evtables. So you need some ordering, basically managing dependencies and how the services depend on each other. When do they start, when do they restart each other. Another set is iptables and UFW from Ubuntu. They're actually not compatible, but they're never gonna lock when operating on iptables. Basically, they don't know about each other, and Nova tries to reload the whole thing, UFW tries to reload the whole thing in some slightly different way, and you end up with no access to your hosts. You have to do the locking yourself, because, well, you're doing loads of operations that pretty much take place at the same time. You install the package, and a couple of seconds later, while it's still trying to start up and bring your instances up, use some operation on UFW and it breaks. Same thing for ordering. AppArmor, C groups, deferred Nova. Okay, so if Nova is supposed to be updated, I'd like to restart it, but AppArmor also got updated, or the profiles got updated, so I want to reload the profiles, but then I need to restart Nova after that. But if I also have a leapfrog update, etc., etc., etc. So there are things to basically consider, especially when you're building your own packages and you need to do an update of something. Those things accumulate. You can end up with something running with the right version, with everything from outside looks okay, but just because of the timing of restarts or reloads, you'll end up with one service not knowing about the previous version of another one. It's hard to find, unfortunately, and well, it's fine when you do it on one system and you find an error, but once you're automating things, it's just going to be everywhere at the same time. So layering all of those updates, first on the development system, then on testing, then on some staging on production, is really helpful because it's pretty much code after all. You need to test code, you need to make sure that it works before you let users go through it. So what do we really use it for? We use it for all service deployments. So everything needs to be done via Chef, for example, in HP Cloud. It needs to be automated. Well, there's no hard cut of if it isn't, but the idea is that it should be. If it's a one-off, maybe something can be do it for all the updates, because that's just how we do updates. Everything needs to be packaged, everything needs to be deployed automatically. And that gives us pretty much consistent environments, and that's the whole thing about automation. We can stand up new environments, and we make sure that developers, for example, get the same thing that would run in production, or as close as possible to. For functional testing, because it's pretty much what was on the previous presentation, we've got our own Jenkins system that checks our contributions before we do something more with them, and it's the same thing. If it needs to be tested, it needs to be tested against a similar system like it's gonna run on. So Jenkins actually spawns an instance, gets the testing done, and the instance is installed in the same way the test environment would be installed. So it doesn't make things look nice and very similar to one another. And again, interfaces, whether it's one-off instance that tests things or proper production environment, it doesn't matter. We know exactly how to find stuff because the interfaces stay the same, whether it's another team or it's something internal to us. We just know that, hey, this is the way I get the location, this is the way I get the password, and it all works. And that's something. Let's say that's a pipeline pretty similar to what we actually do. So developer gets something called Nova in a box, where they get basically an instance with all the Nova components installed and all the dependencies, so plans, keystone if needed, etc. Everything is there. It all looks the same. They get the same packages as they would get on another system, which makes it simple because they can basically test against the same version they're gonna deploy with. They're not lagging behind what was there. We're not cutting an image that just goes stale after a while. It's actually deployed in the same way. So if you test a new release, yeah, it gets all the updated parts, all the updated packages, all the updated ways of deployment.
So do you generate a new image on a regular basis, or do you have an image
No.
that gets updated
So
in the deployment when you create the instance?
so basically, when it gets installed, it will, you can trigger an install, and it will get updated via chef, so it will basically get the same update. And as mentioned before, Jenkins, yeah, same thing happens whether it's developer testing locally or Jenkins doing the functional testing. That the same thing happens. Testing environment, just a larger development environment. Production, again, that's testing actually, well, all the testing happens before, so we can at some point start saying, yeah, this is the actual version that's officially reviewed, controlled, tested, approved, and that's something mentioned. Basically, it allows us to make sure that what we're testing against is not some stale version. It's actually updated when we need it to be. So deploying the updated packages becomes just the same for developers as it is for the next layer. And in some cases, I guess this got to places where some people like, well, you could debate whether that's the right way to do it or not, but there are also some choices we made. So for example, deployment actually says which version of chef cookbooks we deploy, not which version of code, because it's so important that it's actually over the code. We care what we deploy, not about pieces. The whole code becomes a little piece in what we do. So it can get updated, it might not, some other piece might be updated, some dependency might be updated. What actually gets deployed is new version of description, of automation, of whatever you want to call it. New version of description of what we want to have there. There was a lot of debate about it, so I guess there are people that would say maybe it's not the best option, but that's one way to do it. And I would say with enough services, you're always gonna have custom things. It's the same as with previously mentioned cookbooks. Well, for us cookbooks, for someone else maybe Puppet Manifest, something like that. You can start with something simple, but you're always gonna diverge. I think there's just no way around that. As soon as you start providing some service that people depend on, you're not gonna want to wait for some update even if you know it's coming. If you have your own version that fixes something, you want it straight away, and that's how we went into. That's how our diverging started, and I think there's just no good way to keep close with someone else's automation. Just everyone's gonna be a little bit different because they have different customers, different needs. So this is something that we're actually working on lately. Everything needs to be updated automatically. We're not there yet, but this is something really useful because once you go from updates being something that some designated group of people have to do, to make it's just if you transfer it to just being, yeah, I want a new version, click done, that's really helpful for either developers or testers or whoever else, where they can say, I want this part updated because I'm starting to depend on it and it's not been updated in that specific configuration yet. So making it as simple as possible is just saving lots of time because they don't have to raise the ticket for someone else to do it for them. And the same with new deployment. If there are no manual steps, then it just saves a lot of everyone's time. As long as you can prepare the configuration beforehand, of course. There's no running away from that one. And I think there's the global trend of DevOps. So basically, developers need to know something about operations, and I think they need to learn how to automate their deployment, because in the end, it's actually their code and it's gonna run in production. People are gonna depend on it, people as in customers. So if it's all just throwing your code over, okay, this is now done, deployed, no, it's not working as it should, oh, that configuration needs to be changed, oh, but how do I configure that? It's like, as soon as one person can actually not even do the whole thing, but understand what the deployment is all about and can either provide the specific instructions or even do it themselves. Well, I hope that will happen one day, that everyone will just say, yeah, I can automate deployment of my own code. I know what needs to be changed because I understand how it runs in production. That would be something great. But then there's the whole there's a number of new bugs that can just occur because of, well, deployment being automated now. Before we didn't have that bugs because everything was triggered by hand. I mean, before the automated systems became popular, when things were triggered by hand, they just happened once. When you don't do that, a lot of new things can happen, like, okay, is my configuration actually written in a way that it will never change, and when the data doesn't change, will it try to restart the services for some reason, or will the services stay there? So, for example, everything can look great, but every 15 minutes you're losing a request. Why? Because the service is restarting. Why? Because the order of 2 lines in the config files weren't sorted. We actually ran into that one way too many times, because it's just hard to spot when you're looking at the configuration file template. You just say, okay, for like ERB from organized template, you just say, okay, for each element in that hash, or for each key in that hash, print out key equals value. For example, when you're listing filters or default quotas in Novacom. But okay, if they're sorted, then Chef says, okay, config file change, I'll restart the service, and it's the API service, so some request is missing. It's not something that can be caught before, or at least it's hard to see. We don't know that's gonna happen. Or what happens if we execute some commands in a not usual way, like all the time reloading abnormal profiles. We run into bugs that people don't know about because no one has that usage pattern. It's just something they didn't do. And similar thing, what if you have some interaction between 2 services? One service changes, so the other one changes, so on the next run the other one changes, so the first one changes. So some changes can just oscillate between different services, especially when you have different teams taking care of them. You're not exactly sure what the other team is going to do. So even if you're really trying to be sensible about what you do with your service, there's some interaction that that's just hidden in the interface. I guess there's some time before we learn how to deal with that. So yeah, I guess my point was, okay, so we're starting to automate things, and if you're going to have large deployments of OpenStack, they're gonna be the more customers you have, the more customized they will be. And we're gonna have different needs, and I guess that's okay. But there are things to try, like making sure that every single piece is in some way formalized. As long as you don't do it by hand, then you cannot at least analyze what happened. Maybe you get some logs, maybe you can restore the server, even in the critical situation. Sorry. Maybe you can basically say, okay, can't rescue that anymore, let's kill it, bring up new server, and it just works. Yeah, also, if anyone was actually interested in that, we're hiring. Automation and